everyone, my name is Brooke Buckner, and I am in Chem 1005 Biochemistry, and I am addressing both Case 3 and Case 4 in the Unit 2 case studies. So case number 3 talked about a young man, a 5-year-old, whose mother brought him in and said that he had been complaining of constantly being thirsty and also urinating frequently. So upon bringing him in, they took a test to measure his insulin levels, both at baseline and both after an hour. And what they found was, compared to a control, he had elevated he had low insulin levels compared to that control. So that is indicative of type 1 diabetes. And in this case, insulin, which is normally secreted from the beta cells of the pancreas, is not able to be secreted, and therefore, instead of insulin doing its job of normally taking up glucose in the cells, that glucose continues to be circulated throughout the bloodstream, resulting in conditions like hyperglycemia. And so if we were to assess his blood glucose levels, more than likely they would be above a normal range. And this high glucose reading is indicative both of the glycogenolysis pathway and a gluconeogenesis pathway, because both processes the body is trying to synthesize more glucose because there's no hormone signifying or telling it to stop. So in the case of glycogenolysis, the body is breaking down liver glycogen. And in case of gluconeogenesis, there's the production of glucose from other metabolites, non-carbohydrate sources such as lactate and propionate. But under normal conditions, when an individual has functioning beta cells that can secrete insulin normally, this is increasing the glycolytic pathway, and therefore glycolytic enzyme activity. And key enzymes involved in this process include phosphofructokinase 1 and pyruvate kinase. And in that state, once those enzymes are elevated, it will repress enzymes involved in gluconeogenesis, such as pyruvate carboxylate, phosphoenolpyruvate carbonase, and glucose 6-phosphate. However, the type 2 diabetes, in a case of type 1 diabetes, it results in the stimulation of these activities, or the gluconeogenesis and glycogenolysis activity. Therefore, these enzymes will be elevated. So both pyruvate carboxylase and phosphoenolpyruvate, both regulatory enzymes of gluconeogenesis, will remain active because in this state, the body is behaving as it is still in a fasting state. So therefore they remain elevated in a diabetic or a fasted state. Pyruvate carboxylase is activated by acetyl-CoA, and phosphoenolpyruvate carboxykinase is activated by glucagon. And remember, glucagon is the hormone that is opposing to insulin. So where insulin stimulates the uptake of glucose, glucagon really stimulates the release of glucose in the bloodstream when the body is in a fasted state or a diabetic state. Moreover, when glucagon is released, the concentration of cyclic AMP leads to the activation of cyclic AMP dependent protein kinase, and their activation of this enzyme will deactivate and phosphorylate pyruvate kinase, which happens to be the main enzyme involved in the glycolytic pathway or glycolysis. Okay. So week 4 presents with a 2-month-old female who is brought in because upon breastfeeding, she goes into disease spells, or jittery spells, not disease spells, jittery spells, and although she's had nothing else to eat, these jittery spells, or she's just not really appears to not be digesting the milk well. And upon lab results, this patient has hypoglycemia. So in contrast to the case study before, this infant has low blood glucose levels. But other than that, the patient presents no other symptoms. And it's also pointed out that epinephrine was administered, and I'll get to that in a minute, but epinephrine was administered, but it did not result in an increase in blood glucose, which is really interesting. So one of the last key symptoms that this patient presented was for the liver edge, and upon palpating, the physician could tell that there was hepatomegaly, so an enlargement of the liver. So based on these symptoms, it is most likely, compared to the 4 enzymes listed, it is most likely that this patient is experiencing a glycogen storage disease, or should be diagnosed with a glycogen storage disease, because their body is unable to utilize the glycogen. And even though the shaking and the patient presents symptoms of other enzyme diseases, such as hereditary fructose intolerance, there are other things that make it so that the glycogen storage disease makes it probably the key diagnosis. Compared to galactosemia, the patient does not present a cataract in the eye, which is a common symptom of a galactosemia. And then glucose 6-phosphate dehydrogenase is the primary enzyme involved in the pentose phosphate pathway. Now, the pentose phosphate pathway has 2 key products, NADPH and ribose, a sugar. So the product NADPH is utilized by glutathione peroxidase, and that's really key for red blood cells. So this prevents red blood cells from becoming saturated or really toxified with reactive oxygen species. So it detoxifies the red blood cells, preventing oxidative stress, because if the red blood cells undergo oxidative stress, that could lead to ultimately hemolysis and death of these cells. And in this case, a common symptom for that would be skin discoloration, like jaundice. And this patient did not present any symptoms of skin discoloration, so that we can rule that out. One of the key pieces of information leading to the probable diagnosis of the glycogen storage disease, we'll go back to that case of after administering epinephrine, there was no increase in blood glucose. So in the fasted state, glycogen phosphorylase catalyzes the pathway of glycogenolysis to increase blood glucose concentration. So hormones, one of them being epinephrine, activate cyclic AMP, which under normal conditions phosphorylate glycogen phosphorylase. So phosphorylation of this enzyme should lead to increased glycogenolysis, so resulting in the breakdown of the glycogen in the liver. However, in this case of glycogen storage disease, there's a deficiency in enzymes such as liver phosphorylase, which is responsible for, it helps in the process of glycogenolysis. So instead of breaking down this glycogen for fuel, the glycogen remains stored in the liver, accumulating, ultimately leading to hepatomegaly, which is also another symptom of this patient.